Orifice plates, they are a type of flow rate sensing device which are also known as the obstruction meter. The orifice plates, they are also known as the obstruction meter because these devices act as an obstruction in the fluid flow. Obstruction means that they are going to restrict the fluid flow or the fluid flow is going to change. Okay. So they are acting as an obstruction or as an obstacle in the fluid flow, and due to these devices, these orifice plates, or due to this obstruction, the change in the pressure occurs. So due to the presence of an obstacle in the path of the fluid flow, there is a change in the fluid pressure, and this change in fluid pressure is dependent on the rate of the flow. So by measuring the pressure changes first before the obstruction and after the obstruction, we can measure the pressure difference, and by measuring the pressure difference we can find out the rate of the flow. So by measuring the difference in the flow before and after the obstruction, because before the obstruction is placed, the pressure, the fluid flow is different, and after the obstruction, the pressure will be different and the fluid rate will be different. So before and after the obstruction, there will be a change in the pressure. By measuring this pressure difference with the help of a differential pressure sensor, the rate of the flow can be determined. So in this way, these orifice plates, they works by acting as an obstruction or obstacle in the fluid flow. So that is why they are known as the obstruction meters. Okay. And this is how they measures the fluid rate or the flow rate by measuring the pressure difference in the fluid flow. So we can say that these orifice plates, they are a type of indirect methods of measurements. Because this orifice plate, it is not measuring directly the flow rate of the fluid, but it is measuring the pressure difference, and by measuring the pressure difference, it is finding out the rate of the flow. So it is an indirect method of flow rate measurement. Change in pressure is proportional to the flow rate. So it is an indirect method. Also, it is a mechanical device. Okay, so the construction of this device is such that it is acting as an obstacle in the path of the fluid. So it is using a mechanical means for the measurement and also an indirect method for the measurements. So this was just an introduction about the orifice plates. Now let us see the basic principle of working of the orifice plates. As I have said that they does not measure the flow rate, but they measures the pressure difference. So let's see that how the flow rate is measured through it. Now, as these orifice plates, they are acting as an obstruction in the path of the fluid flow. So due to that obstruction, the changes in the velocity of the fluid rate are caused. When the orifice plate is placed in the pipe which is carrying the fluid, and the fluid whose rate we want to measure, rate of flow is to be measured. So orifice plate, due to the presence of the orifice plate, a pressure drop is going to occur, and this pressure drop, it varies with the flow rate. Now, the construction of the orifice plate is such that it is acting as a restriction or obstruction, and the velocity of the fluid will be maximum at the maximum restriction, and at this point the pressure will be minimum. So orifice plate, it will have a point where maximum restriction is provided by it. So at that maximum restriction point, velocity will also be maximum, but pressure will be minimum. Okay. So due to this orifice plate, pressure difference is created, and this difference in the pressure before and after the orifice plate, that can be measured with the help of a differential pressure sensor. And this pressure difference is measured using a differential pressure sensor, and when this pressure is being calibrated, this pressure is going to become a measure of the flow rate, or we can say that this pressure difference is proportional to the rate of flow of the fluid. Okay, so this is the basic principle of working of the orifice plate. Now this flow rate, it is given by the formula. Okay, so this is the flow rate. QA is the flow rate. CD is the discharge coefficient. A2 is the cross-sectional area of orifice. A1 is the cross-sectional area of pipe. And P1, P2, these are the static pressures. because we are measuring the pressure before and after the orifice plates. So P1 and P2, these are the two locations where we are measuring the pressure difference. So flow rate is given by this, and you can see that this is directly proportional to the difference in the pressure. So this was about the basic principle of working of the orifice plates, that how they measure the flow rate by measuring the difference in the pressure. Now let us see the construction of orifice plate. The orifice plate, it basically consists of two devices. One is the primary device and other is the secondary device. The primary device is the orifice plates itself. Okay, and this orifice plate is converting the fluid flow into the pressure difference. Okay, so due to the fluid which is flowing and this orifice plate, a pressure difference is being created. Now this secondary device, it is a differential pressure sensor. Generally a U-tube manometer is used for this. Manometer is also it is a device which is used for the measurement of pressure. So differential pressure sensor here is the U-tube manometer, and this U-tube manometer is going to measure the pressure difference, and this pressure difference is proportional to the flow rate. So the work of the primary device is to create the pressure difference, and the work of the secondary device is to measure that pressure difference. Okay, so orifice plate, it consists of two devices, primary device and the secondary device. Primary device is the orifice plate itself. Now what is this orifice plate? It look like, orifice plate is basically a thin metal plate which is having a hole in between. So orifice plate is nothing but a thin metal plate which is having thickness of 1.5 to 6 mm. Very thin plate is this, and this thin plate is having a hole in its center so that the fluid can flow through it. So orifice plate, it is having a tab or a printed label on it where the specifications of the orifice plate are written. Also the upstream side of the orifice plate, it is a sharp square edge, and it is facing towards the flow stream. Okay, means the fluid is flowing in this direction, and this is the upstream side of the orifice plate which is very sharp and square edge, so that it provides a maximum restriction or maximum obstruction in the path of the fluid flow, so that maximum velocity will be there and the pressure drop will be very much, because when the velocity is maximum, pressure will be minimum. So if we see that how an orifice plate look like, The inner bore diameter means the inner hole, and this is the outer diameter, capital D. Okay, so you can see that this is the shape of the orifice plate. Now let's see the cross section of the orifice plate, that what it looks inside it. So let's see the cross sectional view of the orifice plates. So this is the cross sectional view of the orifice plate. So this is the cross-sectional view of the orifice plate. You can see that this is the pipe, and in between the pipe the orifice plate is being put. Okay, these are the flanges of the pipe, and this pipe is carrying the fluid whose flow rate we want to measure. Now here you can see that we are this orifice plate is providing an obstruction or restriction in the path of the fluid flow. There are 2 points here, 1 and 2, and these points are provided to attach the U-tube manometer, which is a differential pressure sensor. So this pressure sensor is going to measure the difference in the pressure at these two positions, 1 and 2, or A and B. Okay. Now when the fluid is moving here, because here the maximum restriction is being provided, so here the velocity will be maximum and pressure will be minimum. Here it will have a minimum velocity, okay, so pressure will be maximum. So there is a pressure drop here due to this orifice plate, and this pressure drop is measured by this manometer. This at this position the pressure will be P1, at this position the pressure will be P2. So by using that formula we can find out the flow rate. Okay, This is the upstream, downstream, this is the converging area, this is the diverging area. Converging means it's converging here, and diverging means its diameter is increasing here. So it's a diverging part and it's the converging part. These are the flanges, and with the help of these flanges, the orifice plate, it is placed inside the pipe. Okay. Now let's see the operation of the orifice plate, or the working of the orifice plate. So first of all, the fluid which is moving and having a uniform cross section of the flow means when the fluid is flowing in the pipe, it is having the uniform velocity while flowing. Now as soon as it comes in contact with the orifice plate, so orifice plate is having first the converging part. Okay, so first the converging area is here. You can see that before this converging area we are having a flat part here, so to provide the uniform flow of the liquid. So up till this position the fluid is having a uniform velocity. As soon as it is entering the converging part, its velocity starts changing. Okay, and due to the change in the velocity, or due to the changes due to the change in the velocity of fluid flow, the pressure is also changing. So at this position we are going to first measure the pressure P1. So this was in the upstream of the orifice plate, or of the fluid. So fluid having uniform cross section of the flow, it converges into the orifice plate opening in the upstream. Now in the upstream the cross section was converging, while in the downstream the cross section is diverging. Okay, so earlier the cross section was uniform, after that it starts converging, again it comes to uniform, and then it starts diverging. Okay, so in this way the cross section of the fluid is being changing when it is entering the orifice plate, and then it is coming out of the opening of the orifice plate. Now at upstream, conversion of the fluid takes place. And this pressure is called the pressure P1. So when the fluid is converging, it will be having the minimum velocity. Okay, because velocity is less at this part, because it is providing very minimum restriction to the fluid. So velocity will be less, but pressure will be maximum. So P1 is maximum pressure. Now when the constriction or this restriction of, or the bore diameter of the orifice plate is minimizing, it is reducing, so it is providing maximum restriction to the fluid, because now the fluid is flowing through a very small part, so its velocity will be increased but pressure will be minimum. So at that time the pressure is P2. Okay. Now this point of the minimum pressure is called the vena contracta. You can see here that where we are measuring the pressure P2, this point is called the vena contracta. Okay, so this minimum cross-sectional area of the fluid obtained at the downstream from the orifice edge is called vena contracta. Now we have got the two pressures P1 and P2. So with the help of the YouTube manometer, we are going to find out the differential pressure. So this differential pressure is measured with the help of the differential pressure sensor, that is the YouTube manometer, and this YouTube manometer, it records the difference P1 minus P2, and this pressure difference is an indication of the flow rate of the fluid through the pipe. So in this way, by measuring the change in the pressure or by measuring the pressure difference, we are measuring the flow rate. So it's an indirect method, and this is, you can see in the diagram here that P1 and P2 are measured with this YouTube manometer, and the change in the height we are measuring, the change in the pressures we are measuring, and this change in pressure is proportional to the fluid flow. Okay. So this was about the working of the orifice plates. Now comes its advantages. The first and the foremost advantage of the orifice plate is that they are simple in construction. They are inexpensive. Easily fitted with the help of flanges. They have no moving parts, so no friction problem or wear and tear can occur. They are suitable for most gases and liquids. Price does not increases with size. So orifice plates are very simple in their construction, inexpensive, or we can say cheap, easily fitted in the pipe between the flanges, no moving parts are there, large range of sizes is available, they are suitable for most gases and liquids, their price does not increase dramatically with the size. As the size increases, there is no hike in the price of the orifice plates. Also, they can be used to measure the flow rates in large pipes. Predictable characteristics and occupies less space. So we can say that the orifice plates, they are very simple, easy and cheap, inexpensive method for the measurement of flow rate of liquids as well as gases. Now comes its disadvantages. The disadvantage of orifice plate is that it is inaccurate, and this inaccuracy is in the range of 1%. Okay. Also, they have low rangeability, typically 4:1. Also, their accuracy is affected by the density, pressure and the viscosity fluctuations. While installing these orifice plates, at the time of installation, some unrecoverable pressure loss can occur. The viscosity of the fluid also limits the measuring range. They require straight pipe runs to ensure maximum accuracy. Also, the pipeline, it should be full, especially when we are doing the liquid flow measurements. So these are the disadvantages of the orifice plates, that their accuracy is less, their rangeability is very low, and they are affected by the environmental factors like erosion and any physical damage. Also, the fluid viscosity, the density, pressure, that also limits its measuring range. So these are some of the disadvantages of the orifice plates. Now comes its applications. The orifice plates, they are used to measure the flow rates of pure fluids, and it has a wide applicability as it has been standardized and it is used as the primary sensing element for the flow rate. Okay. Also, the types of orifice plates like eccentric and segmental. These orifice plates are used to measure the flow rates of the liquids which are containing the suspended materials. Suspended materials like solids, oil mixed with water, or the steam which is wet. So such type of fluids their flow rates can be measured with the help of the eccentric and the segmental type of orifice plates. So these are some of the applications of the orifice plates and the various types of orifice plates. So in this video, we studied about the flow rate measuring device known as the orifice plate, which is also known as the obstruction meter or restriction meter. Here we studied its construction, its principle of working. We saw its working with the help of a diagram. Then we studied its advantages, disadvantages along with its applications. So I hope that this topic is now clear to you. Thank you.